In this video, I will go over the homework that follows the lecture 2.3. That's called integration resulting in logarithmic functions. Why is it not called integration of logarithmic functions? Because we haven't learned what an antiderivative of ln x is just yet. So we don't know what this is, but what we have learned is that the integral of 1 over x dx is equal to ln of x plus c if x is greater than 0, and we can, if we want to extend the domain to be as large as possible, then we can write it like this, and then this is true for all x's other than 0. So this is what we have learned, and let's try the homework. And here's the first question on the homework. We have an integral of 1 over 3x ln of negative 5x to the power 6 dx. And we shouldn't worry about the 1/3, but what do we do with the rest of it? And here we're looking for the pattern, as always, something like this. We want to have derivative of g and a function of g as a product, and then we would do the following substitution. So we would set a new variable to equal to g of x. In our case, we're going to notice this pattern, and we're going to set up this substitution. We're going to take ln. We're going to take we're going to take ln of negative 5x and set it equal to t. So dt is going to be 1 over negative 5x times negative 5. So it's going to be 1 over x dx, meaning that this together with this can be replaced by dt. And so our integral now becomes this. The 1/3 goes outside. We have 1 over x dx, that's dt. And the only thing we have left is actually 1 over t to the power 6. So this can be rewritten as 1/3 t to the power negative 6 dt, which we can easily integrate. And let me reorganize so it all fits on one page. Let me simplify this, minimize this as an idea. This is what really matters. And let me continue. So by the power rule for integrals, this becomes 1/3 t to the power negative 5 over negative 5 plus c. And we're going to replace t with what t stands for, which is ln of negative 5x and all that to the power negative 5 plus c. So this is the final answer. Great work. My computer is slow. All right. Here's another problem. We have an integral of x squared plus 2x divided by x cubed plus 3x squared dx. And here, what we want to notice is the following pattern. We have a derivative of the function, and we have a reciprocal of this function in the integral. So this is the pattern. This is a thought bubble. So this is just a thought, but this thought leads us to this idea. We're going to do the following substitution. We're going to replace x cubed plus 3x squared with t. So t is now 3x squared plus 6x dx. And if we divide everything by 3, we'll get x squared plus 2x dx. So the integral now becomes the integral of 1/3 dt over t. Simplifying, and this is ln of the absolute value of t plus c, but t is x cubed plus 3x squared. And that's the final answer. Let's try the next problem. We have integral of ln of negative 2x over 5x dx. I'm going to do the substitution. So my substitution is t is equal to ln of negative 2x. So dt is negative 2 over negative 2x dx. So it's just 1 over x dx. And this means that this will be replaced with this. This is the pattern. So we have integral of t divided by 5 dt. So it's 1/5 integral t dt. And this is just 1/5 times 1/2 t squared plus c. So the final answer is 1/10 ln of negative 2x squared plus c. We have an integral of a negative 2x cubed plus x, negative 4x to the 4 plus 4x squared dx. Again, this pattern is very common, so you should be able to recognize it. We're going to set the denominator equal to t, and then dt will simply be negative 16x cubed plus 8x dx. And if we divide both sides by 8, we're going to get negative 2x cubed plus x dx, which now matches our denominator perfectly. So this will be replaced with this. So we have an integral of 1 over t 1/8 dt. So the answer is 1/8 ln absolute value of t plus c, and replacing t with what it stands for to get the final answer. Let's try the next problem. Of course, we now have to do the definite integral, a definite integral, but definite integrals are done using the indefinite integral and the fundamental theorem of calculus. So this is not a trivial integral. So the main question here is, do we know what the integral of tangent x is? Is there a way for us to find out? And it's not obvious, but if we write tangent x as sine of x over cosine of x, and then make a substitution t equals cosine x, then dt will be the negative sine x dx, and that will allow us to replace sine x dx with just negative 1 dt. So after we substitute everything in, we're going to get integral of negative 1 dt over t, which is negative ln absolute value of t, but t is cosine x plus c. And frequently we take it a step further and bring the negative power inside. And what's the reciprocal of cosine? That's just secant. So one formula that you can add to the table of integrals is that integral of tangent x is ln of secant x. So now that we figured this out, now we can solve the original problem. In the original problem, we can take out 2, and because we already know the antiderivative of this, and it's just a composition of tangent and linear function, the antiderivative will be 1/3. So in general, if we had k over here, we would have 1 over k and k over here. That's how it works out. So knowing that, I'm gonna write the answer And the last step will be to simplify this. So we have 2/3 ln of secant pi over 9 there's 3x over here. So we have secant of pi over 3 minus ln of secant pi over 12. Secant of pi over 3, cosine of pi over 3 is 1/2, so secant is 2, so we have 2/3 ln 2 minus secant of pi over 12. I know I said pi over 12, but it should be 3 times that, so it's pi over 4. It's root 2, and ln of root 2 is 1/2 of ln 2. So the final answer is 1/3 ln 2, which is pretty cool. It's pretty cool how it all simplifies. But again, the main takeaway from here is that either you know this fact, so either you know this fact and you use it, or, let me put it in a thought bubble, or you do this substitution by hand. So you would basically do what I did for just tangent. You would do it for tangent of 3x. So one of the two. There's no other option. Alright, so this was 5. Let's go to the next problem. Integral from 2 to 4, 3 over 2x plus 1 dx. We're going to do substitution. T is equal to 2x plus 1. dt is equal to 2 dx. So 1/2 dt is equal to dx. And I'm also going to change the limits. So when x is 2, t is 5, and when x is 4, t is 9. So this is my substitution, and my new integral is from 5 to 9, 3 over t times 1/2 dt. We take out 3/2, and now we have 3/2 ln absolute value of t between 5 and 9. So it's going to be 3/2 ln 9 minus ln 5, and this can be written as ln of 9 over 5. We definitely did a better job simplifying than them. All right, another tangent. So let's see if you remember the formula that I showed you earlier. But we have an integral from pi over 24 to pi over 18 of 2 tangent 6x dx. So now if you remember the formula, then we're going to take out 2, and then we're going to integrate the tangent of 6x. It's going to be 1 over 6 ln of the absolute value of secant 6x. And it's going to be 1/3, and here we have ln of secant pi over 3 minus ln of secant pi over 4. Secant of pi over 3, last time we checked, was ln of 2. Secant of pi over 4 was ln of rad 2. So it's going to be 1 over 6 ln 2. You can pause the video and try to guess the substitution. Here we have a ln of 8 over 5. And looks like this was the last problem. So if you have any questions, feel free to reach out.